All right, we are going to look at some examples involving combined operations and order of operations. The thing to keep in mind for this is that we need to follow order of operations even when we're simplifying rational expressions. That means things like division will have to happen before things like addition. Now, let's just start this off the same way we've started off our other problems and try to write it in a factored form and then identify any restrictions. I want to do the factored form first because I can see in that lovely denominator right there, once I factor it, it's going to be creating some restrictions there too. So let's just rewrite this right underneath. We've got x plus 5 over x plus 6 plus 1 over x plus 4. Temporarily leaving this as division, we can rewrite it afterwards, x plus 6 in the numerator. And our denominator, I believe that will be x minus 5, x plus 4. So we have two numbers that multiply to negative 20 and add to negative 1. Now that we've done this, I'm just going to highlight the parts of this that can give us a restriction. So anything in the denominator, like the x plus 6 and the x plus 4, give us a denominator, give us a restriction. So does the x minus 5 and again the x plus 4. Additionally to that, because we have the division, we cannot divide by 0. That could have been an extra restriction. In our case, we can kind of see we already had that one somewhere. But we still need to check that because it could introduce a new restriction. So keeping that in mind, our restrictions things that x cannot be equal to, x cannot be equal to negative 6, negative 4, and positive 5. It looks like those are all the unique ones offhand. Now that we've done that, we need to ask ourselves, what can we rewrite and what should we do first? Seeing that we have division, I would rewrite that as multiplication, keeping in mind that both multiplication and division happen before that addition in our order of operations. So we have x plus 5 over x plus 6 plus 1 over x plus 4. And rewriting as multiplication, we will take the reciprocal, we'll do x minus 5, x plus 4 in the numerator, and x plus 6 in the denominator. Now I'm going to focus specifically on the multiplication problem since that is what we need to do first. And in doing that, I already see that there is an x plus 4 that can be divided out of the numerator and the denominator, and you know what? That actually took care of our multiplication problem. Well done. So let's see what this looks like now. X plus 5 over x plus 6 plus we have x minus 5 over x plus 6. I'm suspicious at how nicely this is working out, but you know what? We're just going to go with it and hope that that means it is a nice, easy solution. So once we've got this at our addition problem, we need to look for a common denominator, which amazingly, we have a common denominator. That's another point in favor of simplifying first. We wouldn't have had that. So let's rewrite this as a single rational expression over x plus 6. We'll have x plus 5 plus x minus 5. And that looks like it will be 2x over x plus 6 with the three restrictions mentioned above. Fully simplified, not too bad, eh? All right, let's take a look at the second example. Now this one looks amazing. I can tell you are all so happy to see this. Let's just factor. Everything else can come afterwards, let's just factor. So starting off with our lovely bracket, and again, brackets are also going to affect your order of operations, so we need to do this addition inside the bracket before we do anything else. X minus 3 over x plus 3 times x minus 3. Oh, that's nice. Plus x plus 3 over x plus 3 squared, or x plus 3 times x plus 3. And that takes care of our large bracket. I'm just going to rewrite the second bracket so we don't drop it, but I'm not really doing anything to this one. Okay, we do have an addition problem. We do need a common denominator. If there is something you can easily factor out of the numerator and the denominator, like I see this x minus 3 over x minus 3, I would absolutely divide those. Would this be a good time to do our restrictions before I start crossing things out? Absolutely. Thank you for that reminder. Restrictions, including the one I just canceled out. So x cannot be equal to plus or minus 3. We get both of those. Anything else in the denominator, it cannot be -1. Okay, now back to our lovely reducing. So I'm just going to show you what this looks like for the first term, and then we'll keep reducing. This becomes 1 over x plus 3. And the reason that I am comfortable canceling those out even though I'm adding is because I don't have an x minus 3 anywhere in that other expression, so I don't need to keep it. Let's reduce it. Similarly, this one has an x plus 3 we can divide out, leaving us with just 1 over x plus 3. And then this whole thing will be times x plus 3 over x plus 1. This is actually working out so nicely, isn't it? We now have a common denominator for our addition, and we're just going to add our numerators. I am going to actually write out that step, obvious as it is, 1 plus 1 over x plus 3. And then times x plus 3 over x plus 1. Now we can do that addition. And at this point, I'm just going to rewrite it as a multiplication problem. 2 over x plus 3 times x plus 3 over x plus 1. Again, we have this lovely x plus 3 that will divide out, leaving us with just 2 over x plus 1. Amazing. I'm slightly suspicious by how well those worked out, but we're going to hope they're right, and if not, good luck letting me know that I made a mistake. Thanks. Okay, let's move on to some complex fractions. Now, this is the fun stuff. Let's take a look at the right side of this page, and we'll just take a look at the instructions first. So complex fractions, we did look at one of these before, and we essentially treated it like a division problem where we have a fraction being divided by another fraction. There are actually two methods I like for dealing with these. The first method is to rewrite the problem as a fraction divided by a fraction, and I'll show you what I mean on this first example. So method 1 would be to just write it as 5 over x divided by 2 over 3x, and we know how to do that kind of division problem. And you know what? That's not bad at all. It doesn't look too hard. Let's just try method 1, and then we'll come back and discuss method 2. So method 1, division problem, rewrite as multiplication, 5 over x times 3x over 2. Look for anything that can be divided out of a numerator and a denominator, like those lovely x's, leaving us with 15 over 2. For something that started off looking the way that thing looks, that turns out pretty nicely. And that's pretty good for method 1. Now, method 2 is an alternate way of kind of dealing with this, and that would be to look at your LCD while it is still in its lovely fraction form, and use that LCD to kind of manipulate your expression into something nicer. I'm going to take away method 1. Feel free to rewind if you need it. And let's take a look at method 2. Now for method 2, I want to look specifically at my denominators. Yes, both denominators. And I want to find the LCD for those. So the LCD for these ones, I have an x and a 3x, so my LCD will be 3x. What I'm going to do is multiply the numerator and the denominator of the large fraction by the LCD. So I'm going to take this first fraction, 5 over x, and multiply it times 3x. Now I'm multiplying it in the numerator. I must also multiply it in the denominator. You can think of it as multiplying by 3x over 3x. That way we are just multiplying by 1 and writing an equivalent expression. Now just to make this really clear what I'm doing 3x times 5 over x. And then I'm going to do like a ridiculously large fraction. 3x times 2 over 3x. And if it makes it a little clearer for the fraction multiplication, you can write 3x over 1 for each of these. But essentially by doing this now gives me another way that I can look for something that can be divided out. So dealing with just the top fraction, the one in our numerator, this one here, Is there anything that can be divided out? The x and the x, leaving 15 in our lower one. Is there anything that can be divided out? The x over x. Also the 3 over 3, leaving just a 2 over 1 or 2. And that now leaves us with the same fraction, 15 over 2. Now, I'm kind of exaggerating just how large these fractions are. You don't need to draw them that large, especially not the 15 over 2. Let's pretty that up a little bit. But it shows us that we get the same result using either method. So back to our two methods. Method 1 is rewrite this as a division problem rather than having a giant fraction. Method 2 is look for the lowest common denominator of the fractions within the expression and multiply everything in the numerator and denominator by those. Let's take a look at both methods for example 2 as well. So again, we'll start with method 1. Method 1 is rewrite as a division problem. 4a minus 3a over 5. I'm going to wrap this in a bracket, divided by 2a plus 2a over 5. Now, given that I have subtraction and addition happening in those two brackets, I'm going to have to do both of those before I can do any division. I'm not thrilled about this, but we'll make it work. Just for the purposes of seeing that I need to find common denominators, I'm going to write those over 1. Fraction over 5 and a fraction over 1. I would like an LCD of 5, please and thank you. So I'm going to multiply, if it's over 1, I'm going to multiply by 5 in the numerator and denominator. So 20a over 5 minus 3a over 5. That will be our subtraction, and let's do something similar for the second bracket. 2a over 1, going to multiply by 5, making that 10a over 5, plus 2a over 5. And this is where we see this method, as much as it's nice to rewrite as a division problem, it does involve a lot of calculation. We got a subtraction problem, an addition problem, all that lovely stuff. Okay, combining, we have 17a over 5 divided by 12a over 5, which we will then rewrite as a multiplication problem. 17a over 5 times 5 over 12a. This feels promising. What can we divide out of this? We have some 5s that can be divided out. We also have some a's that can be divided out, leaving us with just 17 over 12. Let's take a look at all those steps. So 5 steps to get to that. A pretty clean answer, feels all right. Okay, let's take a look at method 2 on the same problem. Again, I'm going to delete. Feel free to rewind if you need these steps. Okay, method 2 involves finding the LCD of any fractions within our rational expression. Our LCD is 5. We've got that one and that one. They're both 5. That was very easy to find an LCD, wasn't it? So what I'm essentially going to do is take my numerator and multiply everything by 5. Take my denominator and multiply everything by 5. Keep in mind, what I'm essentially doing is taking the whole rational expression and multiplying it by 5 over 5, which is like multiplying by 1. It's not really changing the value. We're writing an equivalent expression. Now what I'm going to do is multiply this out term by term, and I'm just going to do that underneath here. So for example, I need to do 5 times 4a. That's going to be 20a minus, minus 3a over 5, also times 5. Now this is where the magic happens. You're multiplying a fraction that was over 5 times 5. So this is actually just minus 3a. Look at how much nicer that numerator is. Let's do something similar with the denominator. So for the denominator, each of our two terms, that one and that one, are going to be multiplied by 5. 2a times 5 is 10a And then plus 2a over 5 times 5 is just going to be 2a. Is this starting to look familiar to you? I hope so, because this is 17a over 12a, which amazingly, once we divide out those a's, is just going to be 17 over 12. So we do get the same answer, and if we take a look at the steps written for this compared to the previous one, this does feel a lot easier to do. The key to this method is just to notice what is your LCD for those fractions or expressions inside your larger fraction, and then multiply the numerator and the denominator, meaning you multiply each single term in the numerator and each single term in the denominator. If we can do that, this method is probably a lot faster than the first method. All right, I'm going to leave it at that. What I will say is there are a couple of exercises at the bottom with answers provided. Those would be amazing for you to try for a little extra practice. Enjoy!